Hello everybody, and welcome back to the Poor Man's Chemist. In this video, we are going to be creating the chromium analog of potassium ferrocyanide, which is potassium hexacyanochromate 3, or in the old literature, potassium chromicyanide. We are going to be starting from potassium chromate because that was really the only good thing that I had to begin from. As it turns out, ammonium dichromate is not the best choice to start from with this. The first step that we're going to be doing is to convert the potassium chromate, which we're working off of the prep from inorganic laboratory preparations, and we're working at 1/3 scale. So this is 11 grams of that shit, 11 grams of potassium chromate. We are going to reduce this to chromium 3, precipitate out chromium hydroxide, react that with acetic acid to form chromium 3 acetate. And then from there, it's just a real basic react it with aqueous potassium cyanide, or in our case, sodium potassium cyanide. Boil it with charcoal a few times, just like we did for octocyanomolybdate, and there you go. It should crystallize out when you chill it in ice. Now, I've never done this prep before. I did test the chromate reduction just because I've never really fooled around with this too much. Like, if I destroy hexavalent chromium by converting it into more or less harmless chromium 3, I never weigh shit out. I've never been very concerned with trying to produce as synthetically useful and as pure a product as possible. But the textbook gave us a great way to do it, and I think we're just going to go with that. So, like I mentioned before, we've got 11 grams of potassium chromate in here. We've got a little bit more than, I guess this is about 35 mils of hydrochloric acid. And the reason that we have more HCl than we really strictly need is because all the sources I can say are fine say to start from potassium dichromate, not potassium chromate. But the difference between potassium chromate and dichromate is just fucking equilibrium. It's basically just a matter of pH. You get yellow chromate in alkaline pHs, and you get orange dichromate at acid pHs. So we just add a little extra HCl there to convert our chromate to dichromate. Okay, so now that we've got our hydrochloric acid in there, we are going to add some ethanol. This is 95% stuff that I've had drying over molecular sieves, although it doesn't need to be dried over molecular sieves. I'm just picky. Okay. All right, so we're going to add our alcohol in here. And we want to go for about 12 mils. This is a 10 mil volumetric. We don't need to be exact. It just needs to be something that approximates. So long as we've got enough, it's okay. I mean, we're going to boil the excess out anyway here. And indeed, that is our next step, is to turn on the heat and let this stuff stir. Okay. Don't lose your mind. It does not take long for it to start to go dark, but in order to get the reduction to happen fully, you've got to heat it up. When I was doing this yesterday on my practice run, when I first started heating it up, I noticed a very fruity smell. It reminded me very much of the inside of a ripe passion fruit, or maybe like persimmons, because we have this big ass persimmon tree that drops a fuck ton of those things every year, and they just kind of have a characteristic smell when they start to ferment. But then it kind of goes to some kind of like chemically cancery odor, and that's acetaldehyde. You can't miss it, man. I mean, I swear, when it goes from something that smells pleasant to something that smells like it came out of the ass end of a chemical plant, you'll know your reaction is happening. the reduction. And what this really is this is just a Jones oxidation of ethanol to acetaldehyde. That's all that's happening here. But, you know, we don't care about the acetaldehyde product. We're boiling that fucking shit off. All we care about is that we get a synthetically useful, relatively clean solution of chromium-3 ions. So, I will come back when this shit goes green. Alright, so our solution has boiled for a while longer and then has sat here until it's at room temperature now. What we need to do now is precipitate out chromium-3 hydroxide. You can use aqueous alkali hydroxide like sodium or potassium hydroxide in order to do this. However, the textbook recommends using aqueous ammonia with the caveat that you do not want to overdo it because chromium has a tendency to form amine complexes, but it is not too hard to get it right. Just want to add it in a little bit at a time. We'll zoom in a little bit more so you guys can see it a little more clearly. You'll notice that we get some chunks of it that redissolve with our stir bar that's possessed. There we go. When we get a persistent precipitate, that is getting to where we want to stop. Look, you fucking piece of shit stir bar. Fucking cooperate, goddammit. And of course, we'll test the pH of the solution to make sure that it is indeed alkaline. Okay. Another thing you can do is you can see if you're still getting precipitate there when you're hitting it, it probably means you haven't gone far enough. All right, now we have our chromium-3 hydroxide. What we have to do now is filter it. This shit is an absolute pain in the ass to filter. We are supposed to filter it and rinse it well. And we have to use it while it's still moist too, so we aren't going to have a chance to be able to weigh it again and adjust our stoichiometry. We kind of have to use all of this. I have been toying with the idea of centrifuging it and then just mixing it up with some distilled water in order to rinse it, and then either centrifuging it again or just filtering it from that point. I don't know. I haven't decided on what I'm going to go with. Since we do need to dissolve this in acetic acid, I mean, I guess if some of it sticks to the filter paper, it's not the end of the world. We could always just, you know, soak the filter paper in a dilute acetic acid solution until it's all dissolved off of there and rinse it in with a little water, and we got to evaporate it down anyway to get rid of any excess acetic acid. So I think we can make it all work in the end. We won't be able to crystallize the chromium-3 acetate. At least the textbook says we can't. And if it falls in line with me trying to crystallize chromium-3 salts, my experience with that, yeah, all the best you can hope for is this gummy gunk that might crystallize over a very long period of time if you just let it sit there in a bottle. I don't know. Y'all got a trick to getting that shit to crystallize? Put it in the comments because I would love to know what it is. Anyway, moving on. All right, so it's the next day. We have our filtered chromium-3 hydroxide. I just gravity filtered it in the end. That ended up being the easiest way to do it. I just rolled up a paper towel and stuck it down in the neck of the funnel and then used some coffee filters. I just kind of doubled them up, and I'll be damned if that didn't work wonderfully. I trying to do it by vacuum filtration was a absolute pain in the ass. Fuck that noise. Anywho, so since we are working at 1/3 scale, the textbook says to add 33 mils of acetic acid to this. And if the fly buzzing around my head does not fuck off, I swear to God, it's going to be the last thing it ever fucking does. Every time when I start trying to film some shit, oh, it's the South Carolina wildlife, which was nowhere to be found right up until I pushed record. Then all of a sudden it's everywhere. Okay. This is going to take a little bit to heat, or to break up, rather. So, what the textbook says to do now is to obviously get all of this to react, and then to heat it up and evaporate it down until it is almost dry. Do not evaporate it to dryness, or you will end up with a basic acetate. You don't want that. So you're going to get it to almost dry when it's like this tacky, gooey fucking mess. And then once you get it to that, since we're doing it in 1/3 scale, we're going to reconstitute it in 60 mils of water. And then that is going to be the solution of chromium acetate that we are going to react with cyanide. Speaking of which, I need to get to work making some sodium potassium cyanide. As I have come to discover, that stuff will dissolve to a very limited extent in boiling methanol. It's kind of a pain in the ass, and it's the potassium ion that's causing the problem. Potassium cyanide is less soluble in methanol than sodium cyanide is. I think with sodium cyanide that will work just fine. It does work with the sodium potassium cyanide. It just takes a shit ton of methanol in order to make it work. Anywho, just FYI. None of that really matters, of course, because all we really need is for the cyanide to be in excess. We just don't want it in a massive excess, but it's already going to be in a slight excess anyway. So, we go over by a little bit. I don't think that's really going to hurt anything too much. We'll just have to destroy the waste solution that's left after crystallizing the potassium hexacyanochromate with bleach or something. Anywho, I will come back when I have the solution and we are ready to move on with adding the cyanide. Okay, so it occurred to me that people may not have seen something like this, where the textbook says to evaporate down the chromium acetate until it is kind of a tacky, gooey paste. Well, this is what they're talking about. It is very difficult, in my experience, to get chromium 3 salts to crystallize. I don't know why they just do not want to do it. This is usually the best you can hope to get. I have left stuff like this to sit, and over a long period of time, just sitting there, it will crystallize. It kind of looks like it's forming little crystals here, so it might with time. Anywho, what we need to do now with this shit is reconstitute it in 60 mils of water. That's probably going to take for fucking ever. So I'll come back when we have our solution. I went ahead and I made up the sodium potassium cyanide yesterday. I did a double batch. I don't know exactly how much I've got of it. Once I have calculated the exact mass of the cyanide that I have produced, I will adjust the stoichiometry accordingly. Again, I think we're okay so long as the cyanide is in excess. I don't think that excess cyanide is really, like, if we overshoot it and go a little bit too excessive beyond what the textbook says, I don't think that's really going to hurt anything, because the chromium is going to be as complex with cyanide as it can possibly fucking get. So, I mean, we'll waste cyanide and that'll suck, but other than that, I don't think it's going to hurt our prep. But we're going to try to keep everything as close to stoichiometric as possible, because I don't have cyanide to just be throwing away. Anywho, I will come back when we are ready to add the cyanide to this shit. Okay, so we have finally arrived to the point where we have our solution of chromium acetate and we have our cyanide solution. We needed about half of what I made when I did the math. This solution of cyanide has 0.465 grams of sodium potassium cyanide per milliliter, and we needed about 50 mils of it. Now, the textbook says that we have to pour this into this while this is boiling. So it is heating now and stirring. Got a little bit here, just in case we need some extra. I don't know, I guess I'm going to have to figure out something to do with the rest of that cyanide. Now that it's dissolved in water, it won't keep for too terribly long. I actually don't know how long it will stay good for. If it stays cold, I mean a while, but I need to find something to do with it here in the near future. Anyway, I will come back when this is boiling and we are ready to move on. All right, everyone, our solution is just beginning to boil here. So what I'm going to do is I'm going to turn on the stirring here. Oops. And hopefully it's actually going to keep going. And we are going to slowly and carefully add our chromium 3 acetate. I have no idea what's going to happen here. Okay. Oh, smell. Wow. Funny smell. Don't know what that's all about. Hello, funny smell. I don't think I can smell cyanide, so that might just be acetic acid. Okay, other stir bar. Don't you fall into my shit. Man, what is that smell? That smells weird. It's pretty and red, though. I don't want to die out here. Okay, now we have to add 1.5 grams of activated carbon and let this stir and boil for several minutes. Man, I don't know what the fuck that death smell is, and I don't want to die doing this shit. I mean, you know, I guess. If I have to die, let it be doing my craft. That's dedication, by God. Or insanity. Take your pick. All right. Let's put that over here. Got a lot of wind today, which is making this a pain in the ass. I'm going to let this boil. Then we have to filter it through some sea light in order to remove all of the carbon. And then the textbook says to evaporate it down in an evaporating dish to take off about 1/3 of the volume. And then we've got to boil it with some more carbon, filter it one more time, and then cool it down. And we should have our final shit. So we're on the home stretch here, people. Yay! Okay, people, so this has been evaporating down now for hours. The textbook said to evaporate it down over a steam bath, but the volume was so great, like 200 mils, it just wouldn't be efficient, especially considering this is my only hot plate. I really need to get a different one. This is what our solution looks like now. Focus, piece of shit. You can see some kind of red jizz has precipitated out of it. The textbook didn't say anything about that, so I'm not sure if that's good, bad, or otherwise. But what we're supposed to do now is to add activated carbon to it, just like we did again. I'm going a little heavy here. I know we'll lose some product, but I'd rather it be pure. I'm not stressing too much about the yield I get. I just want it to be pure. Whoa! Trying to get all that fucking carbon mixed in there. Otherwise it just floats on the fucking surface. Okay, So this has to heat and sit for several minutes at this same temperature. Then we're going to filter it through sea light again. I already have that set up and ready to go over there. So we're on the home stretch here, people. Once it's filtered, what I'm going to do is because I've got to go to work, I'm going to cover it with some parafilm. I'm going to put it in the refrigerator. The textbook says to chill it in ice and our product will precipitate out. Hopefully, sitting in the refrigerator for several hours while I go to work will achieve the same effect. And then we'll see what we get when I get home this afternoon. And if God was with us or not. Anyway, I will come back when there's something to show you guys. Okay, people, well, it wouldn't be an early transition metal cyanide complex if it wasn't a complete fucking pain in the ass. This shit will not crystallize for nothing. I'm evaporating it down now over boiling water. On the plus side, we're not getting any more of that funky precipitate that we got it the last time we heated it. That's cool. It seems to be concentrating nicely. It's at about 100 mils now. I overfilled it a little bit, but that's fine. It'll evaporate down a little bit more, and then we'll try to crystallize this motherfucker again. I'm sure it's the right stuff. I tried adding a little bit of this to a beaker that had some absolute ethanol in it. I did indeed get a yellow precipitate. The problem with going that route is that, number one, it looks like it takes a fuck ton of alcohol to get it to work properly. And mostly what you get is this fucked up orange oil that is so reminiscent of potassium octocyanamolybdate. Oh my fucking god, I had like flashbacks to that shit. And if it was gonna be, now that orange oil, if you dry it out, eventually turns yellow and chemically behaves as if it is our product. It takes for fucking ever to dry though, and if you heat it up, it decomposes. Because of course it fucking does. So I don't really love the thought of going that way. I figure I'll let it evaporate down to the point where I can pour it out of here and it's not going to spill all over the fucking place. And then we will try crystallizing it in ice water again. And I swear to God, this has to work this time. I also tested little bits of this solution with cobalt chloride solution and copper sulfate. Both times it gave me the characteristic precipitates we're supposed to get. It's the right shit, man. I don't know why it's orange, but we're supposed to get yellow crystals from it. We do get a yellow solid from it with the alcohol. I don't know. Best I can figure is it being chromium 3. I mean, chromium does have a +2 oxidation state, and there is a potassium cyanide complex of chromium with it in the +2 oxidation state. It's very not stable in air. It rapidly oxidizes to the +3 oxidation state, like most other chromium 2 compounds. So I mean, it can't be chromium 2. I don't think it's chromium 6. I think this is basically chromium's answer to ferra with an I cyanide. In other words, hexacyanochromate 3. It's the same fucking oxidation state. But ferrocyanide isn't yellow, it's orange. If you dissolve it in water, it's orange, like this. So, I don't know. I don't know. Chromium's such a pain in the ass. Okay, people, we have got it. Finally. What I did was I evaporated it down to about 75 mils total volume, and then I covered it in parafilm and let it sit in the freezer overnight. And that did it. I think what the deal with this shit is that it's just a slow crystallizer. Would have been nice if the textbook had mentioned that. So, I mean, you can chill it in ice like the book says, and the solution will hit 2 degrees C, and nothing will appear to be happening. But if you let it sit in the cold, like I said, in the freezer for several hours, eventually it will start to crystallize out. And then once it starts, it's one of those, you see a few little crystals, and then I come back and I check it less than an hour later, and it's like, it's all dropped out. Okay, so what we're going to do now is we are going to vacuum filter this shit. The textbook says that we can get another crop of crystals off that solution, which that's kind of cool. I don't even care. I'll just be happy with what we've got here. I don't even give a fuck. So let's go and filter this shit. Holy butt fucking shit, people. Would you look at that? A yellow salt, exactly like we're supposed to get. Yay! Now, the textbook says that we have to rinse this with alcohol with 25 ml portions, so a third of that, in order to remove potassium acetate. And this is why you can't really use you can use another chromium salt. Potassium acetate is freely soluble in ethanol, but potassium chloride, potassium sulfate, and potassium nitrate are not. Let's see. Let's get that solution out of there so we could easily get more crystals out of it. Might as well. This was such a pain in the ass and such a production. I might as well get as much as I can. Yeah, we can easily get one more round out of this shit. Okay. My concern is that the last time I mixed this aqueous solution with alcohol, if it's just a little bit of the aqueous solution, yeah, it works just fine. But if it's a lot of it, you get this godforsaken orange oil that is an immense pain in the ass to deal with. All right, are we focused, piece of shit? Here we go. The final step. Oh. After we plug the vacuum in. Okay. Wash this with a little bit of ethanol. Get rid of that potassium acetate. Get the fuck on, potassium acetate. Nobody likes you and nobody wants you around. Okay. Don't want to go overboard, but this stuff, I don't think it's very soluble in alcohol at all. Alright, that should get it, I would think. Yeah, see how much was removed? A lot of that was potassium acetate, boy. But that's okay. That is expected. It's always like that. I don't know. I think we might have more than I think we do. One more for good measure. I really would like a pure product. Plus, it'll make it easier to dry. All right, I'm gonna let this, I'm just gonna let the air suck through this here for a little bit, and then we're gonna take it off, and I think we'll be just about done. Okay, people, here we go. This is it, man. And that was just the first round of crystallization. We got a fair bit of this shit. Um, I'll do one more round of crystallization and we'll see, we'll get as much as possible. I'm just going to put this in the desiccator and let it dry, and then I will be able to bottle it, and then I will finally have it as part of my collection. Oh my God, this is so fucking great. Oh, this is awesome. I don't know of anybody else that's made this stuff. Um, I tell you what, these early transition metal cyanide complexes, man, they're pains in the ass. They make you work for it. But by God, when you finally succeed, it is so fucking gratifying. Holy fucking shit. I was gonna test this stuff, but the video is already getting long. I'm certain it is potassium hexacyanochromate 3. There's nothing else that it can be. I've already tested it as I've been making it. You can take it to the bank, people. This is potassium hexacyanochromate. Oh my God, that is so fucking awesome. All right, well, this video is already really long, so I'm going to wrap this up here. If you enjoyed this video, give it a thumbs up, and if you didn't like it, give it a thumbs down, even though nobody can fucking see it anymore on YouTube, but on the other platforms we sure can. Subscribe, comment, share the video far and wide. Donate a few dollars if you enjoyed this content, because my God, this was an expensive prep to do. Yeah, even a few bucks is extremely helpful, man. Chems are expensive. Anywho, until the next one, you guys, I will see you later. God damn it, that's so fucking great. I have fucking done it. Yay! I've made chromium cyanide complex my bitch. Haha, add it to the list. Oh, this is so awesome.